Hello class, this is section 5.3, the binomial distribution. So some variables can be used only two outcomes, which is outcome can be satisfied in exactly two categories. So for example, coin tossed, and then there'll be a head or tail. And the multiple choices questions, so even though it's a multiple choices of 5 options, one should be the correct answer, and the other 4 is going to be the incorrect answer. So that's still we can consider as a binomial. And thus, the answer choice can be classified the correct and incorrect. And this situation are called the binomial experiment. So each repetition of the experiment is called a trial. So in order to be a binomial experiment, there's four condition has to be satisfied. So first one has to be the fixed number trial. So it cannot be the infinity many. And then number two, each trial can be only two outcomes, or a cup can be reduced to the two category. So either success or failure. And three, the outcomes of each trial must be independent each other. And then the probability of the success must remain the same for each trial. So a success is a binomial experiment is neither good nor bad, but success just means that the result was what the researcher was looking for. For example, a multiple choice test is given, and the outcomes are either correct or incorrect. If the researcher is looking for the probability of the incorrect answer, that could be the success. If the researcher looking for the correct answer, that means correct answer will be the success. So it depends on what you think is a success. All right. So classify the binomial or not. So let's see, look at the example. So classify each of the situation as a binomial or not. So the first one, rolling a standard die, which means die has options for could be 1, 2, 3, 4, 5. With the 200 times, but this is not a binomial because it could be 1 or 2 or 3 or 4, so more than 2 outcomes. In B, survey 100 shoppers asking for their favorite exercise shoe brand, which is there are more than 2 the shoe brands, right? It could be the Nike or Adidas and Under Armour, right? And New Balance, So yeah, so more than the 2, so it's not a binomial. And survey teenager asking if they play the video game Halo. Oh, so asking for if they play. So they'll say yes or no, right? So this case is yes or no. Yeah, it's a binomial. And ask 300 viewer if they recall the singing a Coca-Cola commercial during a particular show. So if they remember it, they'll say yes. If they don't remember it, they'll say no. So yeah, it's a binomial. And also E, test 4 brands of aspirin because of 4 to see which brands are effective. Oh, that's not binomial, right? Okay, the outcome of the binomial experiment and corresponding probability of these outcomes are called the binomial distribution. So this gonna be a notation for the binomial experiment. So n is gonna be number of the trial, x is the number of the success, and then the p of s is the probability of success, and then p of f is the probability of failure, and then p is going to be numerical probability of the success, and q is a numerical probability of the failure. All right, so we are using that. So binomial probability of the formula. So as a formula, we are using this form, but NCX is the same as exactly this one. Okay, so if you use this one, it's going to be same as this one. So these are the equal to. All right, so let's look at the problem, then see what we're going to do with this. So probability of the rolling twos. A 6-sided die is tossed 5 times, so this is the number of the trial. Okay, so that's the limit of the finite trial. A success is tossing 2. So when you try it 5 times, and then thinking about the tossing A2, so you might get none of the. You don't get any of the 2. That's a 0. You might get 1 out of trial, and then 2 and 3 and 4 and 5. So yeah, you might have everything just turn out to be the 2, right? So n equal to in here. So So n equal to 5. Okay. And then I want to say p of the 2, which is p is 1/6. And then q must be subtract 1/6 from the 1, so which is 5/6. And then I think we can start from here. So if you plug it in into the, put the n factorial over n minus x factorial, so you got 5 factorial, and then 5 minus 0 factorial, and 0 factorial, and 1/6 to the 0 power, 5 over 6 to the 5 minus 0 power, which come out as a 0.4019. For the, how about you got one chance to get a 2, which is 5 factorial. Now you got 1. So you get 5 minus 1 factorial and 1 factorial, which is 1/6 first factorial and 5/6 to the 5 minus 1 factorial, come out as 0.4019. And then for the 2, so what if you have a 2 times of 2? So 5 minus 2 factorial and 2 factorial. And 1/6 to the second power and 5/6 to the 5 minus 2 power, which come out as 0.1608. And 5 factorial, now you got 3 of the 2. And 1/6 to the cube, 5/6 to the 5 minus 3, which is 0.0322. 5 factorial, 5 minus 4 factorial, and 4 factorial. 1 over 6 to the 4th factorial, 5 over 6 to the 5 minus 4, which is a 1. It becomes 0.032. And then 5 factorial now, 5 minus everything is just a 2. And then 0 factorial. 5 factorial, sorry. So 1 over 6 to the 5th power, 5 over 6 to the 5 minus 5 power, which becomes 0.0001. All right, let's answer the question. There are 3 questions follows. So A, find the probability of getting exactly the 3 2's, which is this case, right? So getting exactly 3 2's means we're having a 5 factorial over 5 minus 3 factorial, 3 factorial, which is 1 over 6. We already have an answer in the table, but I'm just going to write down again, which is going to be 0.0322, which is the same as this. Find the probability at least 3 2's. So we're going to be, at least means has to be the greater equal to 3. Okay, so it could be 3 or 4 or 5. So which is same as x equal to 3 plus p of x equal to 4 plus p of x equal to 5. So in order to find that, 0.0322, 0.0032, 0.0001 come out as 0.0355. And probably the n most 2, which is n most 2 means it's going to be the less than equal to 2. Same as p of 0, p of 1, p of 2. And then we already found the probability, so I'm using it as a 0.4019, another 0.4019, and 0.1608 come out as 0.9645. Okay, so that's it. All right, let's look at another problem. Now, probably of the too much concern. In a survey, 3 or 4 students said that the course shows too much concern for criminal. Find the probability that at most 3 out of 7 random selected students will agree with this statement. So as a n here is going to be a 7. And then the p is going to be 3 out of 4 people said that, which is q is going to be 1 subtract the p, which is 1 minus 3 over 4, which is same as 1/4. So this time we need to find the n most of 3, so which is x must be less than equal to 3. So in order to do that, we have to find the p of 0, P of 1, P of 2, and P of 3. So the n is going to be a 7 factorial of the 7 minus 0 factorial, 0 factorial of 3 over 4 to the power 0 of 1/4 of 7 minus 0. And then we'll get the number plus. Now P of 1 means 7 factorial of 7 minus 1 factorial. And then 1 factorial. Then 3 over 4 to the first power, 1/4 of 7 minus 1. And then P of 2 means 7 factorial of 7 minus 2 factorial and 2 factorial. 3 over 4 to the power 2 of 1/4 of 7 minus 2, 3. And plus, 7 minus 2, what am I saying? Okay. And then the last one, P of 3 is 7 factorial, 7 minus 3 factorial, 3 factorial, and 3 over 4 to the third power, and 1/4 to the 7 minus 4 power. So if you calculate that, you get the 0.0000. You got 0.00128173 for the second one. 0.01153564 for the third one. And then you get 0.00576782 for the last. Add them together, it becomes 0.07056. So that's the answer for the example 3. All right, example 4. The probability of the wanting toy. So if 20% of the children were reported to want a particular toy, use the table to find the probability that. So exactly 4 of the 7 children want a toy. So in here, I can say n equal to 7. And then x is a 4 for this case. Okay, so I want to x is can talk about later. And then the p is 0.2, which is q is subtract the p from 1, which is 0.8. So exactly 4. So p of x equal to 4. So you can use this one though. Combination 7 choose 4 of the 0.2 to the 4th power and 0.8 to the 7 minus 4, which come out as 0.029. If you round it, okay? Now, and most of 3, which is p is, x is less than 3, which is same as p of 1, p of 2, p of 3. Oh, p of 0 first, sorry about that. And p of 2 and p of 3. So p of 0 means c 7 choose 0, and then 0.2 to the 0 power, 0.8 to the 7th power minus 0. 7 choose 1, 0.2 to the first power, 0.8 to the 7 minus 1. C 7 choose 2, 0.2 to the power 2, 0.8 to the 7 minus 2. And last one, C 7 choose 3, 0.2 cube, and 0.8 to the 7 minus 3 power. So if you do that individually, you got 0.210, 0.367, 0.275, 0.115, which come out as 0.967. Okay. Now, what about at least 4 of the children wanted toy? So which is at least 4 means x must greater equal to 4. So in order to find that, p could be the 4 and 5 and 6 and 7. So using those, C 7 choose 4, 0.2 to the 4th power, 0.8 to the 7 minus 4. C 7 choose 5, 0.2 to the 5th power, 0.8 to the 7 minus 5, plus C 7 choose 6, 0.2 to the 6 power and 0.8 to the 7 minus 6. 7 choose 7. And then you got 0.2 to the 7th power, 0.8 to the 7 minus 7 power. So number you should get 0.029, 0.004, 0.0, almost 0, 0.000, and then you got 0.033. But also for the last questions, P of x is greater or equal to 4, which is the same as, it becomes 1 minus P of x is less than equal to 3. So in order to find then you got 1 point, but we already find the P is less than equal to 3, which was 0.967. So you got 0.033, which is come out the same as this. Okay, so you can do those. Alright, next page. Now, the mean and variance and standard deviation of the binomial variable can be found using the method for any probability distribution, but there are shorter mathematical equivalent formulas for the mean, variance, and standard deviation for the binomial distribution. So mean is equal to the product of the number of trial and the probability of the success. So this is what you need to remember. For the variance is n times p times 1 minus p. Then standard deviation, you put the square under the variance, which is this is what it is. So this formula are especially helpful when for a binomial experiment, the number of the trials are very large. So example 5, mean, variance, standard deviation of binomial distribution. So for a binomial distribution for each, there are 500 trial, which is n equal to 500. And then probability of the success is 0.25, okay? And then you know that Q is going to be 0.75, right? But you don't have to use this though. So in order to find the mean, which is a mu, is n times p, which is n is a 500 times by 0.25, come out as 125. And then the variance, sigma square, is np times 1 minus p, which is 500 times 0.25. And then 1 minus 0.25, which come out as 93.75. Sigma is going to be square root of sigma square. So whatever sigma you found it, and then use a square root and then a2. Okay, all right, that'll be the answer. Okay, so the next page, which could be a last page for the problem. So example 6, mean and standard deviation of the number purchasing internet service. 32% of the other internet users have purchased product of the services online. For random sample of the 200 others internet users, find the mean standard deviation for the numbers who have purchased goods and service online. So first of all, the number we have a 200. And then the P is going to be 32%, so 0.32. So find the mean n times P, which is 200 times 0.32, which is a 64. And then standard deviation is about sigma of np times 1 minus p. So n is going to be 200 times 0.32 times 1 minus 0.32, which come out as 6.59697. All right, example E. Mean and standard deviation of number of the students. In a survey, 3 out of 4 students said that the course shows are of the 200 students who have the randomly purchased projects or service online is our deviation for the group of 7. Random select the students who will agree with the statement. So in here, so we're looking for the actually n is going to be a group of 7 students, right? And then the probability says 3 out of 4 is a p this time. So in order to be a mu, n times p, which is n is a 7 times p, which is 3/4. So it come out as 5.25. And then standard deviation is going to be the np times 1 minus p, which is 7 times 3/4. and 1 minus 3/4, which is 1.1456. Okay, last problem. Mean and standard deviation of the number of the children. In a survey, 20% of the children were reported to want a particular toy. 7 children, what are the mean and standard deviation of number of the children who wants the toy? So n equal to 7 and p equal to 0.2, which is mu equals n times p, which is 11 times 0.2, which is 1.4, as a sigma, and p times 1 minus p, which is 7 times 0.2 times 1 minus 0.2, which is 1.0583. Alrighty? So that's about the binomial distribution. Thank you for listening.